Welcome to the physics session BSc third semester, paper name Geometrical and Physics and Optics, Electricity 1 and Basic Electronics. In this paper, Unit 3rd, Theory of Dielectrics and Moving Coil Galvanometer. In this sixth session, we learnt about relationship between D, E and P. D, E and P. Here, D is the electric displacement vector and E is the electric field intensity or electric field E, and P is the electric polarization. Now we see electric intensity. So electric intensity is an electric field intensity at any point in an electric field is numerically equal to the force experienced per unit positive charge placed at that point. The direction of the electric field intensity E is same in the external electric field. So electric field intensity is the numerically equals to the ratio of force experienced per unit positive charge. It is in the obtained in the direction, it also in the applied electric field direction. So it is represented by an E is equal to F dividing by Q. F is the applied force, Q is the unit positive charge. F is measured in terms of Newton and charge is measured in terms of Coulomb. Therefore, electric field intensity it is measured in its unit in Newton per Coulomb or volt per meter. It is another term. So now we see dielectric polarization or polarized vector, electric polarization vector. So when a dielectric slab having a thickness small d, it's placed between an external electric field, it's placed between two electric charged parallel capacitor plate, induced charge Qi will be formed. Induced charge Qi will be formed in the opposite direction of the plates. In this case, positive plate will be formed as an minus Qi, and in this case, in this side negative capacitor plate, it will be formed as an plus Q charge will be formed. Induced dipole charges will be formed on the opposite faces of the dielectric. These dielectrics gets polarized. Thus, the induced dipole moment Pi will be formed, or induced dipole moment Pi is produced in the dielectric. Therefore, dielectric polarization is also defined as an electric dipole moment per unit volume is called as an dielectric polarization or electric polarization in presence of dielectric. It is represented by a vector capital P. Since here small p is the Pi is the induced dipole moment. So capital P polarization is equals to induced dipole moment per unit volume. We know about that the induced dipole moment, it is the product of induced charge into the thickness of the dielectric slab, and the direction of the polarization is always opposite to the electric field. In this case, suppose forward direction is an electric field, polarized vector, it will be obtained into the opposite direction of the electric field. Therefore, it always obtained minus Q2 plus Q charge is always obtained to the minus Q2 plus charge for the polarizing vector direction. Next, the magnitude of the polarized vector is defined as P is equals to Q into D, and volume it can be represented in terms of area into thickness. Therefore, here D and D, numerator and denominator, gets cancelled. We get polarized vector is the ratio of induced charge per area. Induced charge per area ratio is also called as an surface charge density. Surface charge density of the induced or charge or boundary condition. After the application of the electric field within a dielectric material, it will be obtained as an induced surface charge. Induced surface charge density, it has having an unit is an coulomb per meter square, because Q is in charge is measured in terms of coulomb. Area is in meter square or centimeter square. That is coulomb per meter square is the unit of polarization. Next we seen about an electric displacement vector D. Electric displacement vector D is considering a polarization. Now we seen polarization of a dielectric slab is placed between the two parallel charged plates. Polarization will be takes place between two parallel plates of the capacitors. The surface charge density will be obtained between the two parallel plates. In sigma free is the surface charge density of the charge of the capacitor in the plate. Sigma p is the surface charge density bounded or polarized charge. Bounded or polarized charge. Then magnitude of the electric field is between the plates without charged capacitor without a dielectric is represented by E naught is equals to applied electric field is equals to sigma free surface density of the free space and to the epsilon naught. Epsilon naught is the permittivity of the free space. Now we, after the capacitor having an in between these two, having a dielectric material is placed between two parallel plates of the capacitor with the application of the electric field, we will get the polarized vector of the surface charge density of the bounded charges will be formed, that is produces the electric field. Due to the polarization, it is opposite to the direction of the applied electric field E naught. It is represented by the ratio of EP is equal to sigma p dividing by epsilon naught. This is without dielectric medium. This is with dielectric medium. In this case, polarization will be absent. In this case, polarization will be present. Therefore, net electric field within the dielectric material, it becomes the differences between applied external electric field to the polarized electric field due to the polarization. So we want the applied external field is what? It is the sum of net electric field and the polarized electric field. Therefore, polarized electric field will be written in terms of surface charge density is sigma p dividing by epsilon naught will be replaced by this equation. Next, epsilon naught E naught is equals to E plus is sigma p dividing by epsilon naught. It can be, we knowing about that. So external electric field E naught is equals to E plus sigma p is equals to P. Sigma p is equals to P. Therefore, this equation becomes sigma p is replaced by P, polarizing vector. Next, epsilon we can multiply by both the side of the equation by epsilon naught. We will get epsilon naught into E. Epsilon naught into E naught plus epsilon is equals to epsilon naught into E plus P. Epsilon naught, it can be represented electric field. External electric field without dielectric medium is the ratio of sigma free surface charge density to the epsilon naught, which is equals to epsilon naught into E plus P. Epsilon naught and epsilon naught get cancelled. We will get sigma free is equals to epsilon naught into E plus P. So we know about that sigma free at surface charge density of the free space, which is equals to the dielectric vector D. Therefore, dielectric vector D. Therefore, D is equals to epsilon naught into E plus P. The quantity of epsilon naught into E plus P, it is the special significance, is called the electric displacement vector D. Therefore, we will get finally equation D, electric displacement vector, it is the sum of product of epsilon naught into E plus P. This is the relationship between electric displacement vector D and electric vector E and the polarized vector. Until this term derivation will be proved. After some cases they are asking the 2 or 3 marks questions, obtain the relationship between D and E. Now we seen what is the difference between electric displacement vector and the electric vector. We knowing about electric displacement vector, D is the ratio of charge to the surface area. D is equals to Q dividing by A. We can multiply and divide by epsilon naught into K. K is a dielectric constant or relative permittivity epsilon R. K is the epsilon R. So that's why if we knowing about that electric field intensity is equal to E dividing by Q. E is equals to Q dividing by epsilon naught into K into A. Therefore epsilon naught is equals to E naught into epsilon is equal to epsilon naught into K, dielectric constant. So this equation will becomes total, this term is replaced by E. We will get epsilon D is equal to epsilon naught into K into E. E epsilon naught into K, which is equals to epsilon R epsilon. We will replacing this equation. Finally we will get dielectric displacement vector D is equal to epsilon into E. Epsilon is equals to product of epsilon into epsilon R, product of epsilon into epsilon R. This is permittivity in case of dielectric medium. So D it is in the unit of coulomb per meter square, and unit of polarization is also in coulomb per meter square. This is the relationship between D and E. This is the relationship between D and E. In case 2 marks question will be asking, you will write these terms, that's all. Next, the relationship between polarization and electric vector E. So from the equation we knowing about the relationship between E and P is equal to E naught plus E plus P dividing by epsilon naught. From the equation 4.43 we will see. Here 4.43 is epsilon E naught is equals to E plus P dividing by epsilon. Therefore we will multiply this equation epsilon naught on both sides. We will get epsilon naught into E naught, which is equal to epsilon naught into E plus P. Here epsilon naught and epsilon naught will be cancelled. We knowing about K is equals to, or dielectric constant epsilon R is equals to, in terms of electric field, E naught dividing by E. E naught is the applied field and E is the net electric field. So E naught is becomes, I want E naught, that is K into E. K into E. Therefore substituting this value of E naught in terms of the above equation, we will getting E naught into K into E, which is equals to epsilon naught into E plus P. I want P value, therefore these terms will be comes into the left hand side. We will get epsilon naught into K into E minus epsilon naught into E. In this both the terms epsilon naught into E will be common. We will taking the common, we will get P is equal to epsilon naught into K minus 1 into E. Here K, which is equals to the dielectric constant, or in some textbook they will be represented as an epsilon R. Therefore in no dielectric is present. In case of dielectric is present, K which is equals to 1. In case of the dielectric constant, the K is equal to 1. Then polarization is 0. In no dielectric other than dielectric material is used, K is equal to 1, then polarization will not occur, will be 0. This means the current, because absence of the dielectric, there is no polarization will be takes place. In case of the two parallel capacitor, in between vacuum or air will be using, there is no takes place of the polarization is 0. In case only it will be polarization takes place, it is dielectric material will be placed between the two plates of the capacitor. Therefore, P is equals to, we knowing about that equation 4.4 is the D is equal to epsilon naught into E plus P. Therefore, 4.4 in terms of P is equal to epsilon naught into chi E into E. Therefore, which is here polarization vector in terms of the P, epsilon naught chi E into E. Therefore, K minus 1, P is represented as in K minus 1, which is equals to chi. It will be get in due to this equation, P dividing by epsilon naught into E. Rearrange this equation, P dividing by epsilon naught into E becomes K minus 1, which is equals to K. Chi is the electrical susceptibility. Therefore, next, this is the relationship between dielectric constant and the electrical susceptibility. Next, we did the relationship between dielectric constant and the electrical susceptibility. K and chi E relationship, we knowing about that P is equal to epsilon naught into chi E into E in this equation. Therefore, P will be substituting this equation, epsilon naught into chi E into E, which is equals to the relationship between this one, epsilon naught into K minus 1 into E. Here epsilon naught into E will be gets cancelled on both sides. We will get the chi E is equals to K minus 1. I want K dielectric constant, so chi E becomes this side. So, we will getting the K is equals to 1 plus chi into E. K is the dielectric constant epsilon R in terms of electrical susceptibility is 1 plus chi E. This is the relationship between dielectric constant and the susceptibility. So, here today's class we learning about the relationship between D and DEP. Is the relationship between DEP is the D is equal to epsilon naught into E plus P, and also D is equal to epsilon naught into epsilon R into E. Next, P and E relationship, P is equal to epsilon naught into epsilon R minus 1 into E, or this equation is also same as in this equation. K is also equals to epsilon R. Next, this is the relationship between polarization vector and the electric vector. So, now is in the electrical susceptibility, it is defined as the dielectric material which is placed in an electrical field. It becomes an electrically polarized and isotropic dipoles. The electrical polarization vector P is proportional to the electric field. Electrically polarized vector is directly proportional to the net electric field. This is proportionality constant is replaced by a constant term epsilon naught into chi E. Chi E is equals to P dividing by epsilon naught into E, and P is also it is in the relationship between epsilon naught into epsilon R minus 1 E. In this case, epsilon naught into E will be cancelled. Therefore, chi E is equals to epsilon R minus 1 R K minus 1. This is the relationship between susceptibility and dielectric constant. Thank you for watching.